Hi, this is Mark from Ivy Scholastic, and today we're going to do the first test out of the blue book. We're going to start with section 3, and I'm going to use my poor battered copy of the SAT book here. Alright, so problem number 1 asks us, here, let me get my pen out. Problem number 1 asks us, if x equals 4, which of the following is greatest in value? And then they give us our answer choices, and this is a good chance for me to introduce the concept of plug in. And this is when you take some given information from the problem, in this case x equals 4, and you actually plug it into each of the answer choices to see what's the correct answer. So for the first one, we got a 5 times a 6, and a 5 times a 3, a 2 times a 6, a 2 times a 5, and a 0 times an 8. So A will be the largest of all of these products. Okay, now let's go on to number 2. Trains A, B, and C, they're always trains in algebra problems for some reason. So trains A, B, and C pass through a station at different speeds. Now train A's speed is 3 times train B's speed, and train C's speed is twice train A's. And they want to know, what's train C's speed in miles per hour if B's speed is 7? Okay, so let's go ahead and take this tipping of the hat that they've done for us. They've given us that little critical piece of information we need to see that A is 21. And once we know that A is 21, we plug that into here. And then 21 times 2 is 42. And there's our answer, which gives us answer choice E. Okay, and number 3. SAT likes these average arithmetic mean sort of problems. And even though they recycle them and they're different each time, they more or less have the same kind of construct. So here, if the average of x, 5x, and 6x, and by the way, quick review of averages, you take the number of elements when we're dealing with an arithmetic mean / average, and whatever those number of elements are is going to go in the denominator after you sum the 3 elements. Okay, so this is our average, and they tell us that this is 8, and they want us to find x. So here up top we have 12x over 3 equals 8. Multiplying both sides by 3, we're going to have a 12x equals 24. Gives us an x equals 2. We divide both sides by 12. Answer choice B. All right. So number 4, no 2 points on the graph have the same x-coordinate. This, and then they show us 5 graphs here, and this is a disguised way of testing the vertical line test, testing whether or not you know this concept. Now, the vertical line test means that take some graph, and ask yourself, can I draw a vertical line anywhere on the graph that intersects it at more than 1 point? And if there is no way to draw a vertical line anywhere that intersects the graph at more than 1 point, then the graph passes a vertical line test, and we say that it is indeed a function. So number 4 is essentially testing that concept. And, let me get my pen back out here. Let's look at the graphs that they give us. For answer choice A, the graph looks like this, and they have these right angles in here. You can draw a vertical line that hits an infinitude of points right there and an infinitude of points right there. That essentially means that for every x value, there is not one and only one y value, which is integral to the definition of a function. Functions are essentially mappings. They map a domain onto a range, and there has to be a one-to-one correspondence. For every 1 point in the domain, there's only 1 point in the range. Domain and range are just fancy pants ways of saying x's and y's. All right, here's our domain, here's our range. Now I know you don't need to know all this information to answer number 4. The reason why I still want to go over it all, though, is because the SAT test writers recycle this kind of concept in later questions. By the later questions, I mean questions that come later in a section. And when they recycle the concept, it returns with a vengeance, so to speak, and when it's used for a difficult test question. So anyways, functions do a one-to-one mapping. So let's see if B gives us a one-to-one mapping. We got funny looking curve right here. And indeed it does not. Here are vertical lines that hit more than one point, and in fact for that chunk of the graph they hit an infinitude of points. So for every x there can be multiple y's. So for every point in the domain there are multiple points in the range. So let's go ahead and look at C, answer choice 4C. Oh, we got a zigzag. Looks like a lightning bolt, I suppose. It's Harry Potter's scar for answer choice C. And indeed, vertical line test hits multiple points. D, now this is looking promising. All right, we got a big check mark. And you can draw as many vertical lines as you want all over this graph. And they will always only hit 1 point. So in other words, for every x, there is one and only one y. Or, if you want to sound more mathematically sophisticated, for every point in the domain, there is one and only 1 point in the range. All right? I like to kind of conceptualize the domain as a circle, and for any point in it, there's only 1 point in the range. And E definitely does not pass the test. It looks something like this, and vertical line test hits that graph in multiple points. Let's look at number 5. Number 5 is Venn diagram time. All right, so the Venn diagram above shows a distribution of 30 science students who studied butterflies, grasshoppers, both, or neither. What percent of the students studied butterflies only? And here we have our Venn diagram. Butterflies, grasshoppers, both, and then neither. Okay, so butterflies only is going to be 9 students, and they tell us that in total there are 30 students. Now right when I see that fraction, that's looking a lot like 3 over 10 to me, which is 0.3 or 30%. And that would be answer choice C. Now if you can, there's nothing wrong with pulling out your calculator for this and just hitting 9 divided by 30, seeing that it says 0.3 and just circling answer choice C. Now let's look at number 6. Trying to go faster when I do these videos because otherwise I start talking. When I get to talking, I get all sorts of tangential information in there, and I think people have had trouble getting through some of the long videos I've made. Okay, so in the figure above, AB equals CD. What is the value of T? So, and then they give us, here's our A, here's our B, and here's my masterful drawing here. I'm so good at drawing straight lines, right? Here's our D, which is at 6, -3. Now there's a little bit of a trick to this problem. -4, -3 here. For A, we got a -2, 3. And hopefully it becomes apparent why I want to draw out the whole thing. So the fact that this graph, that these lines, go past the X and the Y axes, gives a problem a little bit of a tricky twist. So let's first hone in on the X coordinates. And the reason why I know to do that is because we're dealing with distance. When they say line AB equals CD, they mean this distance equals that distance. All right, and so let's look at the distance of C to D. And the X here starts at -4. That means it takes 4 units to get up to here. And then this X coordinate is 6, which means it takes another 6 units, to get to that point. 4 plus 6 equals 10. So now we know that the distance equals 10. Now that we know that, we can go over to our points A and B and look at their Y coordinates. Here's 3, and it's going to first travel a distance of 3 down to this X-axis here. And then after that, it has to go a distance of 7. And so that lets us, and remember we're going beneath the X-axis now, and so this is a -7. Another way to do it is just to say to yourself 3 minus 10 equals -7. And the value of T then is answer choice C. Let's take a look at number 7. Number 7, if 3x squared equals 4y equals 12, what is the value of x squared y? Okay, 3x squared. You know, it's funny. every other day of the year, students solve for X, or they solve for Y while they're in school, but the SAT likes us to solve for X squared Y or some other construct like that sometimes. So what is X squared Y? Okay, all of this stuff equals 12. We can break this up, this part, into two equations. We got a 3x squared equals 12, which gives us an x squared equals 4, which means x is equal to 2. And then this part here, we have a 4y equals 12, so y equals a 3. And now of course, if we just multiply these two together, for getting this part, we'll get 6. And oh, look at that. They have answer choice E equals 6. They're ready to trap you into that arithmetic error there. So be careful. Go ahead and square that guy. So 2 squared is 4 times 3. And that equals 12 for answer choice D. Okay. Number 8. In the figure above, the circles are tangent as shown, and the center of the circle A is also the center of the largest circle. The radius of circle A is 2, the radius of circle B is 4, and the radius of circle C is 4. What is the radius of the largest circle? Whenever they're talking about radii and circles, be very careful not to confuse diameter with radius. Okay, so diameter is 2 times radius, and we're going to see why this is important as we draw this thing out. We got these look like basketballs to me. Here's circle A, here's circle B, and pretend they touch, and here's circle C. oh, my guy actually looks like a little stick figure here. Okay, I'll stop. Don't do that on the SAT. Okay. All right, and then here's circle B and circle C. So it tells us that the radius of A is 2. So that means this chunk is 2, but don't forget that the entire diameter is 4, okay? And then B is 4 and C is 4. So circle B and C have a radius of 4, so a diameter of 8. And now let's take a look at, what do they want? The radius of this whole thing. So they're going to want this whole length here. So that's going to be a 2 plus a 4 plus a 4 equals 10. All right, of course, E has a 20 there just waiting for you to make the mistake of confusing diameter and radius. But just be careful, and we'll see that we need a circle, bubble in D, number 8. All right, so let's look at 9. And, okay, you know, this is a number line, and one thing you might not know about the SAT is that even though they often say figure not drawn to scale, I've never seen them say that about a number line. Their number lines are always drawn to scale on every test I've ever seen or taken over the years. So you can be confident that when you see this number line, that it is indeed to scale, and there's nothing tricky going on. Okay, 5 tick marks, and the distance between the tick marks is 40. 42 minus 2 is 40. And just go ahead and pull out, go ahead, anytime you have something with equally spaced incremental distances, which on the number line they are drawn to scale, you just need to take the distance and divide by how many tick marks there are for 8. Okay, and so each of these increments is 8. So we now know that this is an 18, and that gives us answer choice D. All right, and let's look at number 10. Okay, in the figure above, what is the value of X? And what they want to know is both this angle and that angle. So 70 plus something is what they want to know. So we already know that the entire circle is going to be 360 degrees. Remember when you play those old school video games like Legend of Zelda, and you did a 360 degree spinning attack with your sword, and anytime you did that, you went in a complete circle, right? So that's a good way to remember that the circle has 360 degrees going all around. And here we have a sizable chunk already taken out of our circle here. We got 110 plus 30 plus 90 plus 70 to figure this out. So let's go ahead and it's good to be able to do all this in your head. I sometimes recommend that if you find yourself making a lot of arithmetic errors, to double check with your calculator or to do it on the calculator, because then you can look over your figures and make sure a silly mistake doesn't trip you up here. And here we have 60. 70 plus 60 is 110. So, because don't forget, you want this whole angle, not just the 60. I'm almost certain they didn't make 60 one of the answer choices. Okay, that's nice. They weren't going to trip you up if you solved just for that. So 110 is answer choice A. All right, number 11. When the positive integer k is divided by 7, the remainder is 6. What is remainder when k plus 2 is divided by 7? For all the modular arithmetic problems or remainder problems on the SAT, I want to show you my preferred fast way of doing it. Then we can show you a little bit more of a formal way in case that's what you prefer. So for the fast way, remember first that when we're talking about remainder problems, we're really talking about stuff like this that you learned, like 7 goes into 9 one time, subtract the 7. 7 does not go into 2, so this is 1 remainder 2, and they want to know, they're dealing with that value when they're talking about remainder. Okay, now when k is divided by 7, so they're saying when k is divided by 7, the remainder is equal to 6. The fast way to solve these kind of problems is to just take what is being divided into the mystery number, k, take that, add the remainder right onto it. 7 plus 6 is 13, and just pretend that is your k. And you can double check it. So let's double check it right now. 7 goes into 13, not quite twice, but only one time, minus 7, and then down here we have a 6. Okay, so it works. Now they say, what is remainder when k plus 2 is divided by 7? So here's your k. Your k plus 2, it's going to be 13 plus 2 for 15. 7 goes into 15 two times. Subtract out of 14, and ta-da, there's your answer, remainder 1. And so the answer choice is B. That's the fast way. Now let's go ahead and talk about the more formal way of doing it. So if you want to know the formal way, you go ahead and here I have my messy handwriting. I wrote all this up already. So here when it says when k is divided by 7, the remainder is 6, you can say 7 mystery variable p plus 6 is how you express that algebraically. Now then it wants to know k plus 2, which is equal, you added 2 to the left. Let's go ahead and add 2 to the right. When this is divided by 7, what happens? Okay, so here we have 7p plus 8. When we divide it by 7, which is the equivalent of pulling out a 7 from the entire thing, so 7p plus 1, that gives us 7p plus 7 with a remainder of 1, because the 7 times 1 equals 7, but 8 minus 7 is equal to 1. So then we see that the remainder is equal to 1. All right, so this is a more formal way of doing it. Especially for those of you who are getting into coding and computer science, modular arithmetic is actually quite important. So maybe there's some extra interest there for you. If you wonder why would anyone want to know this kind of thing, this remainder. Okay, so number 12, the chart above shows the pressure as a function of the depth for every 15 feet of descent into the ocean. If the pressure increases at a constant rate for every foot of descent, which of the following graphs describes the given data? Okay, so when we look at, excuse me, my cords are getting tangled up here. All right, so if we look at these graphs, if we look at the chart, we see that as depth goes up, pressure is going up. Right, just look at the chart. Depth goes 0, 15, 30, 45. It keeps increasing. And pressure, likewise, keeps increasing by roughly, it looks like by roughly 7. All right, and it tells us that it increases constantly. When one variable is going up, I shouldn't draw a down arrow, that's confusing. When one variable is going up and another variable is going up, that's called a positive correlation. right? And positive correlations look like this, roughly speaking. Right? Negative, something that's negatively correlated, that means as one goes up, the other goes, one variable goes up, the other variable goes down. Looks like this. Okay? So you can see, so as x goes up, y goes down in this particular graph. So when we look at that, since we know it's a positive correlation, it needs to, the graph needs to look something like that, we can immediately eliminate A and B answer choices. A and B are right out. Now let's look at C, D, and E. So for C, the pressure they have the pressure starting at 0, but from the graph we see that the pressure starts at 14.7. So we can go ahead and knock that out. And for D, now D is looking quite promising. They have the pressure starting at some positive value. We don't know exactly what it is, but that looks promising. So let's keep that in mind. And then when we look at E, right away we see that pressure is starting at 0 and depth is starting at something positive, which contradicts all the information in the graph. So we're left with answer choice D. Number 13, the first term of a sequence of numbers is 1. If each term after the first is a product of -2 and the preceding term, what is the sixth term of the sequence? Whenever I get these kind of sequence problems, I like to just draw out some space holders for what's going on. So here's the first term, and it's 1. And they want to know the sixth term. So first, second, third, fourth, fifth, and ta-da, here's our sixth term here. So let's just start multiplying by -2. Here we'll have a -2 times -2 again, 4, a -8, positive 16, then a -32. And indeed, that is answer choice E. Number 14. 2x minus 5 multiplied by quantity 2x plus 5 equals 5. What is the value of 4x squared? All right. So let's multiply this out. We got a 4x squared. The positive and the minus are just, the 10x's will cancel out, and we'll have a minus 25 equals 5, and then 4x squared equals 30. And go no further. For on the SAT, underline what it is that they're asking you. If you start solving for x now, we're going to get in trouble. All right, and we're not going to have any available answer choices. So just look right to your answer choices, and we see it's E. Now let's take a look at 15. All right, the coordinates of point A in the figure above are PR, where the absolute value of P, here's PR, absolute value of P is greater than the absolute value of R. Which of the following could be the slope of AB? Okay, so let's take a look. Here's our AB, is going to pass right through the origin, boom. All right, so first of all, you know the slope is negative. So you can eliminate answer choices C, D, and E already, right off the bat, because this is a line that slopes downward. All right, so let's go ahead and A, B, C, D, E. Those three are gone. Okay, now let's think about these absolute value conditions. So in PR, the absolute value of P is greater than the absolute value of R means that the distance from 0 to P is bigger than the distance from 0 to R. So why don't we just plug in something, anything at all. So let's plug in a -1 for P, right? It would have to be a negative something because we're going on the x-axis, we're going this way. So let's say that's -1, and then, but that has to be bigger than R. So how about positive 0.5 right there? Or if you don't want to deal with a 0.5 in the denominator, that's okay. How about a -2 up there, actually? And let's just make a 1 right there, make our lives easy on ourselves. So slope is rise over run. So there, and it's going right to the origin. So let's just compare it to 0. So rise over run. Let's go ahead and go 0 minus R over 0 minus P, which will be 0 minus 1 over 0 minus a -2. It's going to give us a -1 over positive 2. So -½ That happens to be one of the answer choices. Even if it weren't, let's say we use different numbers up here. Even if it weren't, it's still going to be a fraction down here because of this absolute value condition. Okay, so the answer choice, the correct answer is B. Number 16. If 3a plus 4b equals b, which of the following must equal 6a plus 6b? Now, they gave us this equation not set equal to anything, and here we have an equation set equal to some variable, and I tend to like to get these kinds of equations set equal to 0 when they're asking me about the value of variables. So I want to go ahead and subtract the b from both sides. We're going to have a 3a plus 3b equals 0. Now this is where you need to take a look at our other equation and see that 3a plus 3b multiplied by 2 equals 6a plus 6b. And if you multiplied this by both sides by 2, then you would have 6a plus 6b equals 0. And so the answer choice is A. It has to equal 0. Okay, I had to skip ahead on the video so I could draw my masterful artwork here for number 17. So in the middle, excuse me, in the right triangle ABC above, EF is parallel to AC, and F is the midpoint of BC. So if F is a midpoint of this whole thing, that means that this chunk alone is going to be equal to 5 square root of 2, and so is that chunk. And we can go ahead and fill this part in too. Okay, now they want to know the area of this whole rectangular region, which means that we need to find width and height and multiply them together. So with this problem, one thing to notice right away is that this entire triangle is actually one of your special triangles. It's a 45, 45, 90 triangle. And in case you forgot what the ratio of the sides is in a 45, 45, 90 triangle, you can look at the beginning of your math section, and it's going to be S square root of 2. By the way, if you don't know what this means exactly, let's go ahead and talk about that. Sometimes we need to review these things. So that means if this is 45, this is 45 degrees, and this is 90, that means the angles, the sides opposite these angles have those values. So this would be an S, opposite that would be an S, and opposite to 90 would be your S square root of 2. In other words, this side and this side are equal, and the hypotenuse is either of the sides multiplied by the square root of 2. So that's what this special triangle means. And indeed, let's go with this overall big triangle. Since this side and this side are equal, we know that their opposite angles have to be equal as well. And since all the angles of a triangle have to add up to 180 degrees, and one of the angles in the big triangle is 90, that leaves the other two, and other two are the same, 2 question mark, whatever the angle is. That means 2 question mark has to equal 90. And so each are 45 degrees. So this guy is 45 and this guy is 45. But take a look. This has to be 90 right here, because these angles that lie along a straight line have to add up to 180. So if this is 90, then that has to be 90. So I think the SAT test makers really wanted to make sure you knew your 45, 45 degree triangles, because that means that this has to be 45 over here. And so these little chunks off in the corner are also 45, 45 degree triangles, in addition to the whole thing being a 45, 45, 90. Because we know that, here's our 5 root 2, that means this has to be 5 and that has to be 5 because of these ratios right here. So now we got the height of this thing. Well, take a look. When we look up here, guess what? We're going to find some more 45, 45, 90 triangles. Okay, so up here we see that this whole triangular tip here has a 90 degree angle right here, and guess what? The opposite sides have to have equal angles, and because of the reason up here that we just talked about, these have to be 45 degree angles. Furthermore, well, actually, you know what? Let's just not go any. We can break it down to even more 45 degree, 90, 45, 45, 90 triangles if we wanted to, because we can have that be our 90 degree angle and show that this is 45 and this is 90. But we don't even have. We can end the problem now. The madness of of the infinite number of, not really infinite, but high number of 45 degree 90 triangles can end now, because the opposite of the 90-degree angle is this whole side, which is the width of the shaded region. And so the opposite of that is going to be, is going to have this ratio relationship. So we'll take 5 square root of 2, multiply it by the square root of 2, and then that gives us 5 times 2, which equals 10. So this whole chunk here is 10. At last, we could go 10 times 5 equals 50 for this whole region. And let's see, is that, yep, that's answer choice C. Okay, number 18 asks us, what is the value of A? And it gives us this table that I've drawn here. And it says f of x equals k times a to the x power, where k and a are constants. So whenever we have a function, we're mapping a domain onto a range. And now what we talked about earlier is coming into play. And the domain is these x values. And the range are these f of x slash y values. And when I'm dealing with a function, I like to conceptualize it as some kind of black box. And we don't know what's inside the black box, just like we don't quite know what the function is. And the black box can contain operations, including multiplication, division, subtraction, square roots, squaring, things like that. And into the black box, there's a funnel, and domain values go inside that funnel. And then stuff happens to them. Some kind of stuff happens to them that related to the function, and what's outputted are range values. So we're going to do this now. We're going to actually put in some x's into our box, and then we're going to see what comes out. Okay, so let's start with setting up all three relationships. F of -1, so -1 is going into the black box, equals, so once the -1 goes into the black box, a 1/8 comes out. And we have some idea, from this problem's givens, of what's in the black box. Some kind of constant times some other constant. Constants are just, think of them as numbers that don't change. All right, they're unknowns, but unlike variables, they don't change around. Okay, so they're just going to be static numbers to the -1, and we know what will come out is a 1/8. And then we have an f of 0, two constants to the 0, because we're feeding a 0 into the black box. What's going to come out of the black box is now half. And let's see, oh, I'm not running out of room. F of 1 is going to be ka to the 1, and what's going to come out of the box, in this case, is 2. These are our three relationships having to do with the black box, or the function itself. I like to start with f of 0 because look at this value right here, a to the 0. What is any number at all to the 0th power? 7,000, for instance, to the 0th power, it'll always be 1. If you forget that, go ahead and double check on the calculator. Take any number, take it to the 0th power, and it's going to equal 1. So because of that, if we substitute a 1 in for a to the 0, we already get that k equals half. This is good to know because now we have one of the constants and we can start plugging into other places in our formula. It doesn't matter what we choose next, so let's just choose this one. Well, we know that f of 1 is going to be k, which is now we know is half, a to the 1. Now what's anything to the 1 power? Like 100 to the 1th power is just that thing itself, so it's just 100. So any number, let's say m, to the 1 power is equal to m. Another thing you can double check right here. So a to the 1 is just a, and that equals 2. We multiply both sides by 2, and we'll get a equals 4. Okay, and let's see here, number 18, the answer choice, because they're just asking for a. They just want to know what a is. The answer choice is D. All right, number 19. So the pyramid shown above has an altitude of h, and a square base of side m. Since the base is square, we know that all of these sides are equal to m now. The four edges meet at V, the vertex of the pyramid, and each have length e. And let's see, okay, here's our length e. And then it tells us that e equals m. That means all of these edges here are equal to m, which means the figure is actually really quite not drawn to scale. So if e equals m, what is the value of h in terms of m? Now, anytime the SAT asks you what is the value of something in terms of something else, that essentially means they want to know what do you have to do to this, something else, to make it look like the original something. So if it's h in terms of m, that means it's going to be the answer is going to be of the form h equals something having to do with m, some sort of operations performed on m. And indeed, when we look at the answer choices, all of them have something having to do with m involved. So that's what express this thing in terms of this other thing really means. Okay, so let's start looking at this. One thing to think about right when you look at this problem is, wow, all of these triangles have these equal sides. And wouldn't it be nice to be able to do the Pythagorean theorem to relate h to a hypotenuse, and with a hypotenuse being m? That would get h in terms of m. All right, and one thing I'm going to do right away to progress towards doing that is to notice that this altitude has to hit the base right in its center, and all of these edges are equal, and the base's sides are all equal. So right when I draw a little mini square within a square, I'm from this midpoint, this middle of this whole plane of the base, then I'm going to get values of m over 2 on the side here for the length of this mini square within a square. And I can't just go, okay, hey, you know what, I'm going to take this triangle, I'm going to draw this, and then draw up three-dimensionally up to that and take the altitude, because we don't know we don't know what this value here is. That is not equal to m. All right, even though the distance from here straight up to the vertex along the slope of this pyramid is some value that we don't know, and it is not necessarily equal to the edge. So that's one mistake I notice students will make on this particular problem. So you want to avoid conceptualizing it that way. We need to go directly to the edge to get h in terms of m. So let's go ahead and cut this mini square within a square right across its diagonal. Okay, and when we cut it across its diagonal, we can discover the length of that diagonal in terms of m, because we know that this is m over 2 and this is m over 2, and that has to be a 90-degree angle. So now we can bring forth our good friend Pythagoras. We know that this is m over 2, this is m over 2, so m over 2 squared plus m over 2 squared. If we take the square root of that summation, we should get the value of the hypotenuse. So let's go ahead and do that. M over 2 squared plus m over 2 squared gives us m squared over 4 plus m squared over 4, which gets us 2m squared over 4, which gets us m squared over 2. Okay, but don't forget, take the square root of that. If you continue the problem from here just with this as m squared over 2, there will be an answer choice just waiting to capture you. You will think you solved the problem and you have understood the problem, but you will have forgotten this little detail. So don't forget to square root this guy. The square root of the entire fraction is equal to the square root of the numerator over the square root of the denominator, which is m over square root of 2 is the value of that hypotenuse. Okay, so hopefully I'll be able to erase all of this so that we make room. So m over the square root of 2 is right. Oh wait, no, let me not write that yet. Let me erase some more. All right, so m over the square root of 2 is right in there. Now we are almost ready to solve the whole problem. Here we have the h, the altitude. It forms a 90-degree angle with any line radiating along the plane of the base. And so here we have a 90-degree angle there, and the hypotenuse is this whole edge. So you see the triangles coming out of the page towards us. If I redraw that over here, we're going to have m square root of 2 as one leg of the triangle. We're going to have h as another leg of the triangle, and then we're going to have e, which is equal to m, as the hypotenuse of the triangle. Okay, so now bring forth Pythagoras again. I have m square root of 2 squared plus h squared equals m squared. We'll simplify this out. We have m squared over 2 plus h squared equals m squared. Let's go ahead and bring that over here where I have a little bit more white space. Let's subtract the m squared over 2 from both sides of the equation so that we get h squared equals m squared minus m squared over 2. And now I'm going to multiply I'm going to multiply this value m squared by 2 over, I did it again, by 2 over 2, which is the same thing as multiplying it by 1, so it won't change its value. And then we'll have 2m squared over 2 minus m squared over 2. We got like denominators, so we can combine these fractions. And 2m squared minus m squared is just m squared all over 2. But don't think you're done yet. It's all equal to h squared, so we need to take the square root of both sides. And now we're almost done. This is the same at square root of m squared over 2 is the same thing as the square root of m squared over the square root of 2, which is equal to m over, ta-da, the square root of 2, and that is answer choice A. After all that conceptual journey, we have arrived at the end. So this is one of those questions that hits the concept of triangles hard and makes sure that you can extrapolate two-dimensional triangles out of the page into what essentially amounts to three-dimensional triangles. But by simplifying the problem in this stepwise fashion, you're always just dealing with a two-dimensional triangle. Sometimes that two-dimensional triangle is coming out of the page at you like it was here. But it's still, we're still just working in two dimensions when you boil things down. Okay, let's go ahead and look at our last problem of the section, and that's going to be number 20. So, right? When you're on the last handful of problems in each section, just know that what might seem to be the super obvious solution is probably not always, but probably not right, because these are the challenging, more challenging questions rated usually difficulty 5 out of 5 by the test writers. So a salesperson's commission is K% of the selling price of a car. So K% of the car selling price, and let's just put P for price. So it's K% of the price. This is our salesperson's commission. All right, which of the following represents the commission in dollars on 2 cars that sold for 14 grand each? All right, so the price is 14 grand each car. So let's go ahead and put that here. K%, but he did it twice. Okay, so let's add another K% of 14,000 over here. Once we add those two together, we will have our answer. But let's think carefully now. What does percent mean? I mean, just look at the word. Percent. Cent is like a century, and a century is what? 100 years, right? Per is like saying for every, so it's or out of. So percent means out of 100. So that's, if you think about it, that's what you notice whenever you do a trick like, well, okay, what is 12% of something? You go 0.12 times the something. So like, what's 12% of 66? You go 0.12 times 66 is equal to 7.92. Doing that 0.12 trick, that trick itself is actually dividing by 100. That's what, sorry, I keep doing that. That's what I'm doing. So K% means K over 100. It's per 100. So K over 100 of 14,000 plus K over 100 of 14,000 and we got 2 zeros in the denominator. That'll, let's see if I can draw it, write it accurately. We'll knock out 2 zeros here, and so we got 140k plus 140k, which equals 280k, and that is answer choice A. Okay, so that is section 3 of the first Blue Book test, and I hope this was helpful for you, and good luck on your SATs.